thanks to the Institute of Corey for inviting us along to do this presentation this evening. As you can see there, Caterpillar nearly 100 years developing products and services to match customers' work like yourselves, making established power sources even more efficient and fuel flexible. Now, obviously, the title of the presentation is Performance Solutions, but we're really focusing on the technology that Caterpillar developed on in the past, where we are and where we're going in the future. So just briefly a bit about finance. For those who don't know, we've got about 1,600 employees in the UK at the moment, 570 field engineers, workshop engineers, 18 branches up and down the country, and 4 dedicated rebuild locations where we'll take machines in and recondition them. Industries we're most prevalent in is construction, the road building, railway building, waste management, quarrying, previously mining. Obviously mining is declining now. So plant hire, and we're heavily involved with power systems, electric power, industrial applications, getting more involved with data centres like Facebook and Microsoft, supplying them with equipment. Obviously involved in the marine industry for many years in oil and gas. Caterpillar in the UK, Dan, you want to
jump in? Thanks, Alan. So thanks very much. It's a great opportunity to be here, and thanks for having us. So Caterpillar in the UK has quite a large footprint, actually. We have 24 locations across the UK. Actually, 85% of what we manufacture is exported as well. We employ 10,000 people in the UK. This year alone, we're going to be recruiting 30 apprentices in Desford, that's in Leicester. The Caterpillar Foundation has already donated through the period of 2015 to 2021, $3.2 million. On the right-hand side there, you see some of the various entities that we have in those different locations. So we're talking of Cat Defence, we're talking of engines, we're talking about Progress Rail, BCP in Stockton and in Desford. In resource industries, we've got up in Peterlee, this is where our articulated trucks are made. So any articulated truck that you see from Caterpillar has come from that source. That this is the sole source worldwide, any articulated truck you see anywhere in the world, Caterpillar-wise. We've also got Cat Finance, and then distribution services and digital as well. This really here is the main reason we're here, I guess. You know, in the press, everybody is talking about sustainability, about carbon, about future-proofing, about diesel-free sites. There's a lot of talk around batteries and reducing carbon emissions. So this is really where a lot of our technologies can come into play. One of our core values and key strategic focuses is that we are committed to building a better, more sustainable world. By that we mean, we're helping to reduce the carbon footprint. We're working and continuing to work with our long-standing partners and dealers in delivering sustainability, reducing greenhouse gases, reducing the emissions from all of our factories around the world. And we are investing heavily through R&D in new products, bringing new products to market, making our existing products better, coming with new technologies and services that help the likes of you guys in the industry deliver a better cost per ton. This here is just a very high-level view of our 2030 sustainability goals. This is more at a factory level. So you can see here some of the highlights: reducing recordable injuries at our factories by 50%, reducing our own greenhouse emissions from those factories by 30%, reducing the amount of waste that's going into landfill by up to 50%. This is all goals that we're setting ourselves internally to reach and hopefully exceed by 2030. They are quite ambitious and quite aggressive, but this is where we feel we need to go. This here gives you a bit of a timeline or a roadmap around how, for decades, Caterpillar has been innovating in the technology space, been investing very heavily, as I already said, in R&D. Some of the key things I want to pull out here are around, even as far back as the early 1990s, we were coming with tethered electric excavators. We've had, for the same period, full autonomous trucks, mining trucks, 400-ton rigid dump trucks running in mining operations over the world, moving billions of tons without any operators and without any injuries. Another point to note here is the electric drive technology. So through the D7E that we launched, through various hybrid electric prototypes we've got, through remote control technologies, through renewable fuels, HVO, biodiesel, all these technologies we have been developing and we are running today. We have over 1.4 million connected machines worldwide. So through that connection that we have to the machines, we really have a lot of insights around a lot of the data, the fuel burns, the utilization, the everything really around the machines. We have today in production fully electric underground shovels working in the mining industry. But we have those available today. We have generators that are running 100% hydrogen as well. So it just gives you an idea that from the very early 1980s, Caterpillar has already been in that space and thinking about the future. This just goes on to kind of drive home what I've just spoken about. So you see there, top left, 1990s. This is an early tunneling tethered tracked excavator, moving then into the D7E, which is the oval drive or flat drive dozer that I spoke about, into scrap handling, waste handling, again, indoor application through the tethered electric excavator. There you see a mini hybrid electric excavator, which was a prototype, into the D6XE, which is a diesel electric drive dozer. And then the solution there, bottom right, is again a fully electric 20-ton excavator that we have developed in partnership with PON, our dealer in Norway and the Netherlands. We have a lot of solutions today to enable us to reach that better, more sustainable world. So some of the solutions we can offer you in the industry today to make you more carbon efficient are upgrading the fleet. If we move from, say, G series, F series machines into our next gen excavators, we can already talk about differences of 20%. Alan will get into that in a bit more detail in the coming slides. Low carbon intensity fuels, so that's biodiesel, HVO. Our machines have the capability of running HVO today, as well as a blend of biodiesel. Through job site efficiencies, so this is with the likes of Finning FMS coming in to have a look at the sites, try to advise you and manage around how we can make the sites more productive. Is it haul road maintenance? Is it widening haul roads? Do you have pinch points? Do you have pain areas? Is there problems at the crusher, for example, that need looking at? And then the final one there, through our rebuild programs. So Cat machines are built to be rebuilt. It's in the DNA of why you would buy a Caterpillar machine. It's got more than one life, as well as the ability to offer a reman service, which is when a part is worn out, rather than buy that part brand new, you have the option to remanufacture. So effectively, in a simple way, kind of melt down that old part and remanufacture it again using the existing iron in the process. I'm going to hand over back to Alan now.
Yeah.
So, thank you.
Yeah, just following on there from some of the standard equipment, standard features that's been on for some years around. Some of you who's got operated Caterpillar equipment throughout the quarries and industry for a while might recognise some of this stuff. And it's just equipment that's built into the machines to make them more efficient, especially in terms of fuel. Electro-hydraulic controls, load sensing hydraulics, engine idle management systems, bit like in your car where they'll shut off the traffic lights to stop them being idle. If you've got equipment that's sitting around in the quarry, it'll automatically shut the machine off. So there's been technology that's been around on Caterpillar machines for a while. It's about how do they build on the technology that they've already got and advance it to make the machines more efficient. There is a correlation between fuel consumption and CO2 emissions. You can see it illustrated there. Generally, we'll say 1 litre of diesel fuel equals about 2.68 kilograms of CO2. So the more fuel that you consume, the more CO2 will be emitted. And it's just about how you can try and reduce the fuel to reduce the CO2. There is a correlation between that. Now, this is a slide here. There's actually a website, and it's run by the Department for Energy Security and Net Zero. And what this slide is really illustrating here, that the construction industry is really heavy on the fuel usage. And if you're heavy on the fuel usage, they're heavy on CO2 emissions. So there's a real focus on that around operator efficiency, changing how the operators use. Now, they call it non-road mobile machinery. We call it mobile plant in the quarrying industry. For example, training operators to use equipment in the most efficient way. Machine efficiency, again, back to job site setup, and make sure you're actually using the equipment to the best of its ability. The operator training, for example, it's got a note there, for example, upgrading hydraulics to become the most efficient version of the machine that's on the market at that time. And about the process, about how you actually get the stone from the face through the crusher in the most efficient way to minimise your fuel and your CO2 output. So, for example, here in the construction industry last year, well, this is actually 2021 data, they're saying 816,000 tonnes of fuel is the figure that they are banding around. And if you just save 1% of that fuel, you can reduce 26,000 tonnes of CO2, which I think is a really powerful statement. So it's about just how you can improve your fuel efficiency and reduce your carbon footprint. Again, just as Kai had said, there's some new models on the market. Cat 320, if you get the latest generation of 320, compared to the previous one, which was the F series, you're using up to 30% less CO2 per tonne. The D6 XE, which is again with electric drive in it, up to 35% less. 966, 972 XE models, they've been about for a bit of time now. They use a variable transmission in it, different, more efficient technology. It can reduce your CO2 per tonne up to 35%. And we're seeing 980, 982 models in that XE space at the moment, and they're up to 45% less than the previous M series that was before that. Biofuels, HVO fuels, so options that's available with Caterpillar equipment. And again, this is all about reducing the greenhouse gases.
I think let's just go back one there. Some of the key points to pull out here is, no impact on warranty, no engine conversion or updating needed. These machines can take it off the shelf as is without having to do any sort of heavy work, conversion. That's what they call that, really.
Yeah, good point, yeah. Techniques to help reduce fuel consumption and emissions. Well, idle time management, like I mentioned before, is just monitoring equipment through, whether it's the Vision Link online platform, or just keeping an eye on, you know, is a guy sitting in the machine idling unnecessary, going to be switched off. Operator training, we can obviously work with your operators on site, come out, give them one-to-one coaching. Eco drive training is something we did in Scotland before, and it's still available, where we can come out, look at your job site, see how it's set up, and again do that one-on-one coaching and look at the operation and just demonstrate how a few changes can reduce your fuel consumption and therefore reducing your carbon emissions.
And it's generally really well received by customers, isn't it?
Yeah.
That they do see value and benefit in doing that. You know, it's not just that we're coming and teaching you to suck eggs. It's actually there is some value in it, and you do see gains in the efficiencies for the operators.
Yeah. And obviously the equipment selection, it's just, we can come out up front if you're working on a new quarry, a new development, we can run simulators to say, you know, do you need 3 dump trucks or 4 dump trucks, excavators, wheel loaders, what's the proper, most efficient setup for your application? And the technology, there is technology available on machines, if you think CAT grade, to help automate the grading process, boost precision and speed and efficiency. And on your compaction machines, which are your rollers, there's technology built in there that can help fewer passes really. CAT payload is a system that's been built into the wheel loaders for a while, and it's now coming on excavators. And you can see in real time the actual production that's carrying in the bucket, and it helps you hone in on any efficiencies or loss of efficiencies. CAT detect as almost like a radar system where you can see the machine and how it's interacting with other equipment round about the quarry. Is there going to be any impact there? Preventing collisions and that sort of stuff. CAT command is on some certain machines. You can actually remotely operate equipment, so you don't actually have to sit in the machine. So it's trying to make safer, take the operator out of the equation if you're doing it from a safer environment, especially if it's working in certain areas, maybe with unstable faces or whatever. And then the Vision Link technology, which has been around on CAT machines for some time. You know, other manufacturers have got their own version of it, Volvo, Komatsu as well. We still think Vision Link, which has just been updated in the last year, I still think it's the best in the industry. You can even get it in your mobile phone now, so you can see event codes coming through, fuel consumption, CO2 emissions, and you can tie that in with your Vision Link productivity, where you can see in real time the data, track equipment and product health across a complete fleet.
Yes, just so the way to look at that is Vision Link is really kind of individual assets, whereas Vision Link productivity is more looking at a job site in the entirety, or multiple job sites, for example, quarries, where you can manage that site and really get into the data for that site and see how you can again drive efficiencies.
Yeah,
you can look at from basic extraction all the way through to load out on your own highways to yeah.
So that's some of the technology that's around available at the moment.
And a lot of that Alan has just spoken about. Can you just go back one, Alan? Sorry.
Yeah.
So CAT grade, for example, CAT payload, these are standard on our diggers now. Okay. So it's technology that's there, it's embedded, it's within the DNA, you're getting it. It really is, it's fantastic. It's adding a lot of value.
Yeah. So I mentioned earlier on about CAT machines being built to rebuild. In the quarrying industry, it's been taken up quite well over the years. Customers are very receptive to it. You know, why spend all that money on a machine and then, you know, get to the end of the first life and throw it away when you can reuse most of it? We've been doing rebuilds for customers in the quarry industry for many years in Finning, and we still do it to this day. I mean, 50 to 65% cost of the new machine. Good economic value, and it's definitely a sustainable choice. Up to 7,000 parts inspected, reconditioned or replaced. The other thing is Category Man, which has been around for 50 years now. And like Kai said, it's components that's available on the shelf that have been remanufactured, which again is a sustainable solution because it's using less raw materials. You imagine an engine, you know, you're reusing the main block, some of the components in there. And again, it's less in greenhouse gas, using less energy because the parts are being recycled. £140 million material returned in 2022. Reused material, sustainable benefits for Caterpillar and customers like yourselves.
So my name is Jason Ramshaw. I'm North East born and bred, but I've moved around with cats for a number of years. I've been with the company for 39 years now. I would like to get an indication in the room of how many people have been in the quarry business for, say, 15 years.
Quarry stroke mining.
Right, okay. 20 years?
Yeah.
25? 30? 35 years? 40 years?
Wow. Wow.
So it's, you know, it's a wealth of experience. This is where Caterpillar really need to, you know, we have been. I think we need to do more is to talk to the customers about their business, to really understand, you know, what challenges you do have in your business. You know, because this all goes towards, you know, how we build machines of the future. We've done it in the past. What we're showing on this slide here is that, you know, we've got a core fleet of machines today that we build. We've got to look at how we develop those machines because, you know, we can't stop development. You know, we've still got to build machines, we've got to improve them. A lot of the machines have changed to electronics now. You know, I remember the days of the diesel engines, you know, where you go in, you could tamper with them, but now you can't. And I remember the time when that was done, and there was nearly a curfew about it, you know. But times do change, and we have to still change, and we have to move with the times and build the products to be efficient, to bring in the productivity. But at the same time, as we're developing the core, we need to look at the future. You know, need to look at R&D. We need to build machines that we think customers need in the future. We have to put them out there, we have to build them, we have to test them. But in the meantime, we have to look after the core business. So here's a 980 XE. This is a current product. It's been in production since 2010. But as you can see, over the years, we've developed the machine quite substantially. In the beginning, they were quite, the engines were quite, you know, fuel guzzlers. Okay. But as the years have gone by, technology's come in, we've learned a lot. We've refined the engines, refined the powertrains, refined the, you know, how we see parasitic losses. Because it's not just about the engine burning fuel. If the parasitic losses, which is the hydraulic pumps on the machines, if they pull a lot of horsepower out of the engine, you're going to burn more fuel. So how do we make those pumps more efficient, which helps reduce fuel? Okay. So there's all this development still going on. Okay. And as you can see, we've progressed, and up to 2021, we've actually reduced the fuel usage of that machine to 35%. Okay. We don't just do it on the 980 XE. We've done this on a lot of our machines. We had a focus that we, you know, wanted to get to, but also the emissions levels drove us to do different things. You know, the technology, the investment that we had to put in to develop the T4, T3, you know, T5 engines was astronomical. So we thought, well, while we're doing this, while we're spending the money to get to emissions level, let's also try to reduce fuel usage on the systems. Okay. So up to 35% lower fuel consumption, obviously, less CO2 emissions, up to 20% more productivity. So more productivity is that we looked at hydraulic systems. We made them more efficient. They can dig quicker, they can lift quicker. Okay, in some cases, they can actually do a dig cycle itself. It's like a semi-autonomous dig cycle. Okay, 45% less CO2 per ton of material moved. So back in say 2010, this was our aim for 2021. Okay, so we had targets that we wanted to meet by a certain time frame, which was also driven by emissions as well. Okay, well, that's on current product, but then at the same time, we're having to work on future machines. We know that the world is changing. We know that we have targets to hit that the government is setting. You know, the government say by 2035, you've got to be, you know, emission free. That itself is a huge task. It's a massive, massive task. Okay. You know, to a point where do the governments actually understand what that actually means? So it's took some cases of the manufacturers having meetings with the governmental parties to help them understand what type of technology leaps would have to be done to get to that point in time. Okay, to help them understand that. And all the development work that will go in to accomplishing that as well. Okay, but this here is 950 GC. It's an electric machine. What we try to do is when we're building electric machines, the performance of the electric machine has to be the same, if not better, than its previous engine machine. Okay, no power loss. Performance has to be the same, if not better. Okay, so that in itself is a big task because you have to drive motors, to drive the hydraulic pumps, to drive the powertrains. So it's a big change. The battery capacities that we have, 600 volt, but the battery technology is changing every single day. It's improving every single day. Okay, and we have to try and keep up with that. We have to try and understand the technology and how we're actually going to accomplish this in the field. So yes, the machines can have a battery, but then how long is that machine going to last on one battery charge? Yeah, so we've done a lot of surveys, a lot of talking with customers in different applications, construction, quarry, on what they saw as a time where it would suit their working day. Yeah, some of the times that they mentioned we couldn't hit because of the battery capacity, battery technology. You know, but we had to say, well, this is what we can offer. This is what we can build to at that time. Yeah. But as I said earlier, battery technology is changing every single day. It's improving every single day. Okay. So a runtime on a 950 GC is up to 6 hours on a single charge. Machine of this size could be in a load out area of a quarry, loading on highways, you know, with the aggregate. Is that good enough? You know, if it's 6 hours, sometimes if it's in a load out area, the machine could be stood for quite some time, just waiting for the next truck to come in. So is 6 hours good enough for that type of cycle? Okay, so these are all the questions that we have to ask ourselves. Okay. And then looking at the battery solution. So how do we actually, you know, charge the batteries that will be on these machines in a quarry environment, in a construction environment? You know, how do we get infrastructure in there to actually, you know, charge it? We can't pull everything from the, you know, from the infrastructure that we have, you know, on electrical infrastructure. So we have to try and build our own self-preserved system. So we looked at the cells, then modules where we have like a computer part of it, and then we go to a pack. So what we're looking at now is, can we develop a pack, a battery pack that will go in all machines, okay, or it's modular. So you can add batteries to the pack, depending on what machine you have, okay? So you may have 3 different electric machines on site. It could have the same battery pack, but one battery pack could have a stack of 6 for the larger machine, stack of 4 for the mid-sized machine, a stack of 3 for the small machine. But it's the same principle, okay? And you can interchange all the battery packs, stack it up. So this is the type of logic that we're thinking of, but then it's also got to fit within the machine as well. So we're trying to design the battery pack to a certain size, that will fit in all machines that we have. And you can imagine going from a small excavator up to a huge excavator is it's a big difference. Okay. So it's a task that we have. It's not easy. There's a lot of research going on, and but at the moment, this is what our strategy is looking like. Okay. So production today, we have the underground loaders, we have locomotives, we have energy storages. That's in production today. And as I said earlier, we've got prototype machines out there working now, going from a mini hex, to a 320 excavator, 950 wheel loader, also a 906 wheel loader. And that's the battery pack type that's in the middle. You can see the different stacks in there. Okay. Depending on the machine, that stack would vary in height. Yeah. So that's the logic that we're thinking about now for these products. Yeah. And then, charging, different chargers on site. So we have here at the back, it's like a genset type charging system. Okay. But then your standalone chargers that could be, connected to the electrical network that you have on site, just like a car charger. Okay, plumbed in to the system. And then it's just a normal plug that you see on the machines. Obviously, each plug is different to the area of the world that you're in, type 2, type 3, etc. But that's again how we're looking at applying the charging systems on site. Yeah. Unique challenges of a construction site. Obviously, you can imagine there is a lot of challenges that we've got to face and we've got to look at. We've got to understand supply. So, do we take it from the grid? Is the site near a grid? Okay. Is the grid reliable? In some parts of the world, you get blackouts every 3 hours of the day. Distribution. So how can we, can you pull supply from the grid and can you store it and then distribute it to the machines? Yeah. So can you pull it off the grid, charge the actual battery packs and then store them, or have a battery pack charge another battery pack of a smaller size? That type of logic. Yeah. And then transfer equipment downtime. So how fast can you actually charge, or how fast can you exchange a battery pack? You want to look at how you fuel a machine today. How long does it take to actually fill a tank of diesel on one of these big machines? Can you change a battery pack in a similar time? Yeah, that's the types of things that we look at. And then, project phases, the demand itself. We've got to help the customers understand what our logic is with regards to, batteries and charging and things like this. We don't expect just to go and say, right, okay, there's your battery pack, there's your charger, get on with it. We want to help customers understand what we have. We want to help customers learn. We want to learn from the customers. Does it work? Does it not work? What can we do different? Yeah. So the integration and the discussions between the customers and ourselves as an OEM and the dealership spinning, is critical to the success of all of this. Yeah. So that's the end of the presentation. We seem to rush through it there. There was no questions, but is there any questions?
Well, always asking questions. Yeah, so first of all, thanks very much for the talk. That was excellent talk. A lot of work into that. Some a few questions. With electric machines, if you listen to the mining world, there's not enough metals, lithium, cobalt, copper, to fully transition across from hydrogen fuels, to carbon fuels to electric power. So our hydrogen fuel cell technology, are these suitable for trucks and excavators, and where are Caterpillar with this?
We do have some hydrogen engines that we are testing that are in machines. But one of the things with hydrogen is it delivering the power that you need? Okay. And the torque, all of these types of different things. So obviously there has to be a lot of test work. And if, you know, I think all the manufacturers are looking at this is that if they go with one technology, they've got to stick with it. They can't go with multiple platforms because multiple platforms will be quite expensive to administer within factories. So I think there is still a lot of work going on to see which one is most efficient within ourselves. I know that, you know, the likes of JCB are doing this and, you know, quite vocal about it.
Yeah.
But we're still testing.
Though the question about safety, trying to fill up a vehicle with hydrogen, you know,
Yeah.
that safety problem.
Yes. Yeah, I mean,
That's overcome.
the canister that you've got to charge. I mean, it's charged at quite a high bar, PSI. Does that, you know, is there going to be regulations in quarries, on construction sites to say that, you know, you've got to have a safe area, or you've got to have a specific area on the site where you do the charging, you know, or, you know, is the higher risk of something going wrong, and then it could have a downstream effect in the rest of the plant or the quarry or whatever. So again, it's a good question, you know, but all these things that we are looking at investigating.
Second one, that 950 loader, the electric machine, does that battery recharge on the return cycle for the bucket?
No, there's no regen on the systems yet. We do have some regen on some machines. We actually had a regen system on an excavator. I think it was a 336. About 15 years ago.
Yeah.
And it was just where the counterweight is. We had two big accumulator cylinders.
Yeah.
You know, huge, and on your swing cycles used to charge them, and then it used to assist with your digs.
Well, you saw that working time of 6 hours. If a quarry usually works to 8 hours, you know, 2 hours short. So with the regen system on the bucket return, we made up that to get closer to the 8. Yeah.
No, I mean, you know, the regen systems are being looked at, but you know, the machines that you see today, they're not built in yet.
Right.
But again, it's looking at what the machine is doing to really understand this, you know, and have that conversation with your customer to say, right, okay, we've got a battery machine here. What are you going to be doing here? And what's your expectation of, you know, running time?
Yeah.
You know, and we've got to be honest. We've got to be honest about it to say if it's 6 hours, it's 6 hours. You know, and if you're running it constantly, it's 6 hours. But if you're going to run it, you know, every 50 minutes or so, or every 30 minutes, you know, then it's waiting for a while. It's got to be switched off, you know, to preserve that energy.
Yes. Yeah.
You know, then it could last a full shift. So it is dependent on what the machine's doing. You know, some of the larger machines that we're looking at, obviously, we're hoping to get a higher time frame out of the battery, you know, longer duration. But again, it's having that conversation with the customer to help them understand, you know, help us understand what the application is.
I've got one last question. We'll go to the floor. With the autonomous trucks, you know, if you put in a driver in a machine, the fuel efficiency depends quite a lot on their driving style and how heavy they're with the throttle. So the autonomous trucks, are they more efficient in terms of fuel if you put a driver in that truck?
They are more efficient, yes.
So that's quite bad then for the employment, because you would need if they're more efficient, you would need nice driver.
What we've seen is in the mines, on the mining machines that have gone fully autonomous, is that the operators have been upskilled. So you've got to have a control room to look after all these autonomous machines. I mean, on some sites in the world, there's 15, 20 of these autonomous machines. And there's no better having a person that knows the machine inside out, knows how to operate them, knows what things could go wrong, you know, to upskill that person and put him into a control room, you know, to understand what the site's doing, where it needs to go next, you know. So we have seen a lot of that, of the upskilling of the operators as well.
Okay, thank you.
Yeah.
But from the floor, any questions?
We've got one. You say you're gathering data from 1.4 million machines, fuel usage and all this. If I'm Joe Bloggs and I want an excavator and a dumper, I will be aware of what my fuel usage and efficiencies are.
Yes.
But can I share the other information from your other 1.3 million?
No.
So it's
down.
You can't advise.
What you see is tied. Yeah, what you see is tied to your unique customer ID as Joe Bloggs.
Yes, but you wouldn't offer up industry averages or.
You
do
call
benchmarks, don't you?
It's called a fleet benchmarking report.
You do
So they'll
benchmarks.
say like, you've
Yeah.
got a 992 and the industry average is 80 litres per hour, yours is doing 60. So,
Yes, so you would give some feedback as to
Yes.
where you'd be at.
yeah.
Feeling happy with
Yeah,
that.
fitting, you'll do that for you, get them as thing.
Yeah.
But it's all about confidentiality.
Absolutely,
That's why it's set up.
we wouldn't expect you to say that Fred down the roads.
Yeah, even, there's only specific people within Caterpillar that can have access. Because of the development of the stuff with it, I can't even have access. So that's how critical it is.
And how long do you foresee a battery lasting? Not the operating time, but the lifespan of it.
Lifetime.
I don't know yet. I can't answer that. But we can try and get it, we just write it down. We try and get an answer for
An engine rebuilds, what, 20,000?
that. I mean, fuel burn, it's based on fuel burn on the engine rebuilds. So could it be a similar thing on cycles, depending what type of machine it is. But I have no indication yet of what the lifespan is on one of the batteries.
Battery market, because it's almost selling a nice new battery. But
True.
Because your battery recycling technology is not quite there yet, is it?
No.
No, so we build batteries, from new metals, from newly mined metals, put the machines, so that once they're finished.
Yeah.
As today, we can't really recycle them efficiently. Maybe in 10 years' time we can, but today, bit of an issue.
Yeah.
We're not saying that we're only going down the battery route either. We're wide open as to which technologies we will go with. It might be a mixture of all sorts. It might be fuel cells, it might be hydrogen, it might be battery.
Yeah, so I think if you're looking at it reasonably, we can't all go electric for all our vehicles,
No.
buses, cars, trucks.
No.
The metals aren't there to go and do it.
We got the infrastructure.
But we have, and that as well, but we have, hydrogen fuels technology, HVOs, biofuels, and electric vehicles among the spread. We can get by with reduced carbon future. We can't do it with one technology alone though.
No.
I think you read, when you read into, some of the magazines and technologies, and anything can happen over the next few years. A new technology may pop up.
Yeah.
I mean, Toyota's working on this engine. That's it's not nitrogen. It's an engine that's so efficient, but still like a combustion engine. And it doesn't give any gases out. So all the technology and all the testing that's going on at the moment, for me personally, I think that something could come in and change everything.
To me, it's the total energy in, the total energy out that needs to be measured clearer, because the input to produce battery and lithium cells and whatever else to the power it's outputting at the machine level. What is that?
Huge.
If you were comparing that to diesel or to a traditional carbon fuel, where it's a pretty low input to get a good output, it's massive.
I think you're right. If you mine cobalt in Africa, it gets then shipped across to China for processing. It gets from China to USA to make the batteries, and USA back to Europe. It's a massive carbon footprint before it even gets to the machine.
But it's greener.
You believe what you want to do.
It's the output's greener, but it's not. It's the total life cycle.
That's what I'm saying. That if all the technologies together all blend into one to make it a better country, better world. That's fine. But as you rightly say, just going down the electric route, it looks green from the kind of end user, but to get there, it's not very green.
What we're measuring, basing on just CO2, I don't think is right.